Hey, this is Mrs. Rodolphi, and I am going to be going through the Lesson 32-2 practice in the SpringBoard book on page 473. So this lesson is on completing the square. So for 2 equals x squared minus 10x, we want to solve by completing the square. So I'm going to do this on a separate sheet of paper because it does get a little lengthy with the work, so I would definitely recommend getting out another sheet of paper. As I always say in these videos, try it yourself first and then use the video to check your work. If you're still struggling, maybe watch me do this first example, and you should be writing it with me. Anytime you're watching these videos, you should be also writing these down and trying them on your own first. It and try some on your own and use my video to check your work. All right, so the first thing we want to do, so we want it to be in the form of ax squared plus bx equals c. And right now it is, I'm just going to rewrite it as x squared minus 10x equals 2. That means the same thing. I'm just changing the order of it. Then when we complete the square, we want to draw a square on each side of the equal sign. For this one, we will use the formula b divided by 2 squared for what to fill in those squares. 10, so I'm going to put negative 10 divided by 2 squared. Negative 10 divided by 2 is negative 5. I'm going to put in the squares. All right, now we have a perfect. With the factored form, I can go back to this value, negative 5, and I know it's going to be x minus 5 times equals, and then we combine like terms, 2 plus 25 is 27. Now, since we're multiplying x minus 5 times itself, the equals 27. Now I can do the square root of both sides. Square root of 27 and square root of x minus 5. So you're just left with x minus 5. The square root of 27 is not a perfect square. So we're just going to so we have to put that plus or minus in front of it, because you could have a negative times a negative equals a positive, or the positive times that further. So I would definitely reference that bluish purplish paper that I gave you guys in Unit 4 with square root of 4, square root of 9, square root of 16, 25. These are all perfect squares because they equal factors that are perfect squares that go into 27, and I immediately see 9, the square root of 9. So I know 9 times 3, the square root of 9 is equal to 3, so I can pull that out of the radical symbol. Plus or minus 3, and then the square root of 3 is irrational, so I kept that in the radical symbol. One more step, we need to isolate x over here, so we need the inverse plus 5. X equals, now we cannot combine these terms. 3 times the square root of 3, we cannot add it to 5 because 5 does not have 5 in front, plus or minus 3 times the square root of 3. And this is in simplest form. around it. So that would be your answer. So that means that this quadratic function has two solutions, 5 plus square root of 3 or 5 minus 3 times the square root of 3. So these are the two x-intercepts. So I would accept it as this way, plus or minus, or you can rewrite them one with plus, one with minus. Same thing. All right. Try number 4 on your own. Get as far as you can until you get stuck. Use these steps. Remember, it's the same steps, you know, with just different function. And then come back to my video and check your work. All right, so number 4 is 4 x minus 32. All right, so we want, again, to get in the ax squared plus bx equals c. Then I get 4x equals, oh, I'm just rewriting the same thing. I don't get 4x, I get 0 just equals x squared, and then negative 4x minus 4x is negative 8x minus 32. Then I want to add this, and then I'm going to just rewrite it in a different order. So I'm going to put x squared minus 8x. And then I know I'm going to have 32 as my constant, and then plus the square. All right, now to figure out what to put in squared. Our b value here is negative 8. Negative 8 divided by 2 is negative 4 with 16. Now we have our perfect square trinomial. Go back to when you did b divided by 2. Negative 4 is going to be our factor, x minus 4 times x minus 4, which is the same thing as x minus 4 squared. Then we have plus the square root of both sides. X minus 4 equals, and then the square root of 48 is not a I know 16 is a factor of 48, plus or minus 16 times 3. The square root of 6, so plus or minus 4 times the square root of 3. Then I need to get x isolated, so if it's minus 4, I'm going to plus or minus 4 times the square root of 3. That is our final answer. This has two x-intercepts. Pause the video and try number 5. All right, for number 5, negative 2x squared plus 4 equals negative x squared plus x minus 7. All right, so I'm going to add 2x squared to both sides. With plus 2x squared is positive x squared plus x minus 7. Then I want to add my c value, so I want to get all my constants over there. So that's 11 equals x squared plus x. All right, then plus bx, and then plus my completing the square equals 11 plus the square. By 2 squared to find what to put in the square. My b value, if I just have x, that's like 1x, so b equals 1. 1/4. So I'm going to put 1/4 in the, or you can put 0.25. All right, then going back to b divided by 2, that was 1/2. So I know that's going to be my factored form, x plus 0.25, 11.25. All right, this is the part where I want to get rid of, well, hold on. First, yeah, before I do the square root, too complicated. We don't want any decimals in our answer. We want a whole number under the radical or just a whole number, like a perfect square. So what sides of this equation by a number to get rid of this decimal? So I would just start with like 2 5 times 2, that's 22.5. I know that 0.25, like, you know, if you have a quarter, 4 quarters equals $1. So I'm going to try 11.25. So I can multiply both sides by 4 to get rid of my decimal. So that's what I'm going to do. All right. This will give me 45. And because these are all perfect squares, so I'm just going to do the square root before I distribute that, because I know that it gets rid of the squared term, equals, and then plus or minus 45. Then I'm going to do times 1/2 is 1. Plus or minus, I know that a perfect square goes into 45. 5. Then I am going to take out the square root of 9, which is 3, so plus or minus 3. Now I have to isolate x. If it's plus 1, I do the inverse, minus 1. 2x equals negative 1 plus or minus 3. So it is divide by 2. X equals negative 1 plus or minus 3 times the square root of 5 by form. That is our final answer. So no decimals. If you see decimals, you want to multiply both sides of the expression. All right, pause the video again and do number 6. All right, so number 6 is equals 6x minus x squared. All right, so we want to avoid having, you're going to have negative a values, but it makes it more complicated. So let's move this around so we get rid of that. So I'm going to add x and then x squared plus x plus 1 equals 6x. 6x, x squared minus 5x plus 1 equals 0. And then x squared minus 5x. And then I'm going to put that square equals negative 1 plus the square. The value is negative 5. Negative 5 divided by 2 is equals 6.25. So that's what we're going to fill in. All right. Now we can do factored form. So again, you get your factored form from your b divided by 2. So I know it's equals, and then negative 1 plus 6.25 is 5.25. All right, we have a decimal here. We don't want to try multiplying that by 4 to see if that gives us a whole number. Gives us 21. So we're going to multiply both sides. 4 is a perfect square, so I'm just going to multiply this side, which I know is 21, and leave this the same. Oops, there we go. And then I'm going to take the square root of both sides. Square root of 4 is 2, and then I just get x minus 2.5. Square root of 21. Now I can distribute the 2 to everything inside the parentheses. 2 times x is 2x. Equals plus or minus the square root of 21. Plus the square root of 21 doesn't have any perfect square factors. 7, 3. Now I need to isolate x. First I'm going to add 5 to both sides. 2x equals 5 plus or minus 22. X equals 5 plus or minus the square root of 21 divided by 2. So this. All right. Try number 7 and then come back. All right, so for number 7, complete this square value, determine the number of x-intercepts. So this goes back to the example B on page 472, where it gives y equals a times x minus h squared plus k, where negative h. All right, so number 7, y equals x squared minus to this formula, but notice how the only difference is the other ones were equal to 0. This one has equal to y. So constant over with y, so plus 2 is my constant. I'm going to subtract 2 from both sides. Y minus 2 equals x squared minus 2x. Plus the square equals x squared minus 2x plus the square. Same thing, b divided by is negative 2. Negative 2 divided by 2 is negative 1. Negative 1 squared is positive. We have our perfect square trinomial, x squared minus 2x plus 1. And I know my factored form goes over here to what I got from b divided by 2. Plus 1, y minus 1, equals x minus 1 squared. All right, the only difference now is this. Now I just want to move my constant back over to the other side. So I'm going to add 1 to both sides. Y equals x minus 1 squared. Form a equals 1 because there's nothing in front of the parentheses, so that's like that invisible 1. X minus h, x minus plus 1, we're in that vertex form. The vertex is negative hk, so you actually do the opposite sign. So if it's negative 1, it becomes positive 1, and then our y value is 1. So for this one, our vertex is 1, 1. If there's just an invisible 1 in front of these parentheses, a is positive 1. So that tells us that it opens upward. This, that means it has a minimum vertex. So it opens upward with a minimum, the same as the vertex. And we always put the minimum value as the y value, which is 1 in the vertex. So a minimum at 1. X-intercepts there are? Well, if this vertex is at 1, 1, I know that's in quadrant 1 of my graph. So if this is at 1, 1. That's not touching the x-axis here. So there are no sketch. That is totally fine. I'm very visual, so I always kind of draw a quick sketch so I can kind of visualize it because it's hard to in my head. Go ahead and pause the video and try number 8 on your own. I should have done it, so y equals negative x squared plus 8x minus 6. Now constants over to the other side. So I'm going to add 6 to both sides, y plus 6 x plus squared. Now I'm noticing one thing. That by putting it on the outside of parentheses. So I'm going to rewrite this y plus 6 plus square equals negative 1. Negative 1, if we divide 8x by negative 1, we're going to get negative 8x and then plus. So we're taking it and then it changes the signs of everything inside the parentheses because, again, I want x squared to be positive in order to complete the square. Our b value is negative 8 divided by 2 squared, which equals negative 4 squared. Now this is where you have to be careful, and it gets a little tricky sometimes. This is plus 16 inside the parentheses, but which is negative 16. So over here, this has to be negative 16. So if you have anything on the outside the parentheses, before you add it to the multiply it by whatever's on the outside of the parentheses. So that's where it gets just a little extra step here. All right, now negative 16 is negative 10, so y minus 10 equals my factored, I still have negative 1 on the outside, and then I squared. All right, then now we're getting close to the finish. Back over, add 10 to both sides, y equals negative 1 times x minus 4 squared plus 10. We know that my vertex, so if it's minus 4, that changes it to positive 4, and then 10 is the y value. It is open downward, opens downward. So that would have at my vertex's y coordinate, so at 10. All right, and then, okay. Quick sketch. 2, 4, 6, 8, 10, 2, 4. So I know it's going to touch the x-axis at 2 x-intercepts. So 2x. And it helps us to see. It helps us to know that where the vertex is, if it opens upward or downward, has a maximum or minimum, and what value, and how many. All right, going back to the book, number 9. In a model railroad, the track is supported by an arch where y represents the height of the arch in inches and x represents the distance in inches from a cliff. Complete the square to answer the following questions. How far is the center of the arch from? We want that same information we were just getting from, so by doing the vertex form. So let me grab another. So y, again, pause it first, do it on your own first. And, all right, so again, move your constants to the other side, plus 16. All right, we don't want that negative, so we're going to take it out. I'm also going to put my squares, so I'm going to put negative 1 minus 10x plus. All right, then to complete the square, b divided by 2 squared, our b by 2 is negative 5. Negative 5 squared is 25. So I'm going to put 25. Again, negative 25, so that's what we put on the other side. 16 plus negative 25 is negative 9 equals negative. Here, I know it's going to be x minus 5 squared. Now I can add 9 to both sides. Y equals minus 5 squared plus 9. Now we're in vertex form. So going back to the question for A, how far is the vertex is at 5, 9, then I know that the center, that would be 5, and we're talking about, this is like a little mini railroad model, so that's 5 inches from the cliff. So A would be, and then B is asking what is the maximum height of the arch. Well, the maximum height is my y value of my vertex, so that would be 9. All right, number 10, the bubbler is the part of a drinking fountain that produces a stream of water. The water in a drinking fountain follows a path given by y, where y is the height of the water in centimeters above the basin, and x is the distance of the water from the bubbler. What is the maximum height of the water above the basin? So that we can find the maximum height, which is the y value of the vertex. So we have y equals negative x squared. And try it on your own first, and then come back. All right, we're going to subtract the constant y minus 4. I don't want the negative, so we're going to take it outside of the parentheses. Complete the square. We have our b value is negative 6 divided by 2 is negative 3. Negative 3 squared 1 is negative 9 when we write on the other side. Negative 4.5 plus negative 9 is negative 13.5. We can do a factor, go back over here, x minus 3. All right, now I can move my constant back over. 3 squared plus 13.5. This tells me that my vertex is at 3. -3 is +3, and then this is your y value. So this tells me that the max height of the water gets 13.75 centimeters. Is 13.5 centimeters. In the video, I hope it was helpful. Have a fabulous rest of your day.